In this question, they're asking us to calculate the indefinite integral of x squared times the square root of 2 plus x dx. So, I'm going to do a substitution method to solve this, and so we have a few different options for what u should be. Could be x squared, it could be 2 plus x, could be the square root of 2 plus x, or it could be the whole integrand altogether. In this question, I'm going to decide to choose that u is equal to 2 plus x. And the reason I'm choosing it this way is because after doing a lot of these questions, what you start realizing is a lot of times what you want to replace, or what you want u to be, is the thing inside the square roots or the thing inside the power. So I'm just taking a guess here that u might be this, based on my experience. Now, of course, it might not end up being this, and we would have to change our u, but that just comes with a lot of practice. So I'm going to choose u to be this and then see what happens. So if I let u equal this, then the thing that I'm looking for, the integral of x squared, square root 2 plus x dx, is equal to the integral of x squared and then the square root of u dx. Now I have a whole bunch of x's and a whole bunch of u's mixed up here, so the first thing I want to do is get rid of this dx. So I'm going to go over here and do a quick calculation. I'm going to take the derivative of u with respect to x, which is just 1. And then even though this is not a fraction, I'm going to treat it as a fraction and solve for dx, because not only does it help me get the answer, it helps me get the right answer. So if I solve this for dx, I end up with dx is equal to du. And so now I can go back into my actual question and replace the dx's by du. So I have the integral of x squared, u to the power of 1/2. So I've rewritten the square root as the exponent 1/2. That has nothing to do with calculus. That just has to do with what the square root actually is. It's to the power of 1/2. And now I'm going to take this dx and I'm going to replace it by what I just calculated dx to be, which is just equal to du. So here we're kind of in a situation where we've kind of replaced the dx by du, and unfortunately nothing really canceled. This x squared is still kind of hanging out here. So we might be a little bit stuck because we have we're supposed to integrate with respect to u. We have a u here, but we also have an x in the integrand. So this is kind of messed up, and we're not able to go much further at this point. So one might be inclined to think that maybe perhaps a different u substitution, maybe a different choice of u would be a good idea, and it could be a good idea. Usually when you get to this point and you still have x's and u's all mixed up, it's usually a good indication that you should choose a different u. However, one trick that you should be aware of is sometimes what you can do, and in this question you can, is realize that I just need to replace x by something to do with u. And if I look back up here, I have a relationship between u and x. In fact, it's a very simple one. And I can invert this. Instead of u is equal to 2 plus x, what I can do is rearrange this equation and figure out that x is equal to u minus 2. If I demand that u is equal to 2 plus x, and I demand that that be true, well then this also has to be true. If I just put the x on one side and the u stuff and everything else on the other side, this also has to be true. And what does that mean? That means that wherever I see an x, it's actually just a secret u minus 2. So now my integral becomes, instead of this x squared, this becomes u minus 2 squared, u to the power of 1/2 du. So maybe you get this situation and you think, well, yeah, this is kind of complicated, so maybe I need to do another substitution here. But actually, it's much simpler than that. If you actually carry out this u minus 2 squared, you end up with u squared minus 4u plus 4, just carrying out that square, times u to the 1/2 du. And then what I can do now is I can multiply everything in here by this u to the 1/2, and I end up with u to the 5/2, multiplying the u to the 1/2 times u squared, minus 4u to the 3/2 plus 4u to the 1/2. And this is all du. And using my rules about indefinite integrals, I can split this up into the integral of u to the 5/2 du minus 4 the integral of u to the 3/2 du plus 4 the integral of u to the 1/2 du. So all I did was take this indefinite integral of all these terms, and using my indefinite integration rules, split them all up and pulled their constants out front. And now I can actually carry out these antiderivatives. So this becomes u to the power of 5 halves becomes u to the power of 7 halves, because the rule is take the exponent, add 1, so I get 7 halves. And then what I have to do is divide by the new exponent. So this is divided by, or multiplied by 1 over 7 halves, minus 4. And what is this antiderivative? Well, again, I take the power and I add 1, so that becomes 5 halves. And then I multiply by 1 over the new exponent, so it's 1 over 5 halves, plus 4. Same thing here. This becomes u to the 3 halves, because 1 half plus 1 is 3 halves. And then I must multiply by 1 over the new exponent. And then all of these things comes with constants, and I'm just going to pile them all into one giant arbitrary constant, c. Okay, so now what I can do is I go back here and I just simplify things a little bit. 1 divided by 7 over 2. How do we divide fractions? We flip and multiply. This ends up being 2/7. U to the 7 halves, and I know what u actually is. U is 2 plus x, so I can go ahead and replace all the u's by 2 plus x. 2 plus x to the 7 halves. This becomes negative 4 times, if I flip this becomes 2/5. U to the power of 5 halves, and of course u is just 2 plus x to the 5 halves, plus 4. Again, flip and multiply this, so I end up with 2/3. 2 plus x, 2 plus x to the power of 3 halves, plus a constant. And if I want, I can actually clean up some of these coefficients out front, and this becomes 2 over 7, 2 plus x to the 7 halves, negative 4 times, 2/7, 2 plus x to the 7 halves, negative 4 over 1 times 2 over 5 is negative 8 over 5, 2 plus x to the 5 halves. 4 over 1 times 2 over 3 is equal to 8 over 3. So 8 over 3, 2 plus x to the power of 3 halves, plus a constant, and this is the final answer.